Before venturing into different types of eclipses, we must understand and have a basic idea about the physics of shadows. When there is a point source of light in a dark room, every object blocking the light would cast a dark and distinct shadow on the walls. But in case of eclipses, which is indeed a game of shadows, the source of light is the sun, which is obviously not a point source of light. Therefore, any celestial body which blocks the light of the sun will cast three different types of shadows: the umbra, penumbra, and antumbra. Look at this picture carefully. The darkest part is the umbra, derived from a Latin word meaning shadow. This is the main shadow. Any observer in this part would totally obscured from the sun. The lighter shadows formed on both the sides of the umbra is called the penumbra, derived from a Latin word meaning almost shadow. Any observer in this penumbral part will be able to observe the sun only partially, as the obstacle will block the sun with respect to every point in the penumbra. So, the shadow formed in this region is fainter as compared to the umbra. Antumbra is the fainter part vertically opposite to the umbra. We know that the apparent size of an object decreases as the observer moves away from that object. So the apparent size of the obstacle is indeed larger in the umbra than in the antumbra. The point of intersection of the umbra and the antumbra is the point where the apparent diameters of the obstacle is exactly equal to the apparent diameter of the sun from that point. So for any observer lying in this umbral region, the apparent diameter of the obstacle would be greater than the apparent diameter of the sun, and for any object lying in the antumbra, the apparent diameter of the obstacle would be less than that of the sun. Therefore, the obstacle would not be able to block the 100% light in any points lying inside the antumbra. So, the antumbra is also fainter than the umbra. Now, this is a 2D representation of space. In real life, all these umbra, penumbra and antumbra are cones. First, we shall discuss about lunar eclipses. There are 4 types of lunar eclipses: total lunar eclipse, partial lunar eclipse, penumbral lunar eclipse, and partial penumbral lunar eclipses. A total lunar eclipse happens when the moon passes very near to one of the lunar nodes during a full moon. Remember, in case of lunar eclipses, the obstacle is the earth, and as the earth is bigger than that of the moon, the umbral cone of earth extends far beyond the moon's orbit. In other words, the moon never gets a chance to cross through the antumbra of the earth. At the distance of moon from the earth, earth's umbra is far bigger than the moon. So the moon spends a big amount of time crossing through the umbra during a total lunar eclipse, which takes about 2 to 3 hours. But due to refraction and scattering of sunlight by Earth's atmosphere, its umbra is not absolutely dark, as long wavelength red light gets scarcely scattered and reaches the moon, giving it a reddish glow, and we often call it as a blood moon. The moon revolves from west to east around the earth. So the eclipse of moon starts from the left side of moon, starting from the first contact, and ends at its right side during the last contact. Sometimes the moon may not pass very close to the ecliptic or the nodes, so some part of the moon enters the umbra and some part don't touch the umbral part. This makes a partial lunar eclipse to occur. The center of the umbral circle is one of the nodes. So if the moon passes above the node, only its southern hemisphere would be eclipsed, and if it passes below the node, only its northern hemisphere would be eclipsed. In these cases, we on Earth would see the curvature of Earth's shadow only engulfing some part of the moon. Remember, the penumbra surrounds the umbra of the Earth from every direction. So for the moon to reach the umbra, first it has to enter the penumbral region of Earth's shadow. As the shadow of the penumbra is far fainter than the umbra, the decrease in the amount of moonlight is barely visible to the naked eye. Now our journey is taking the eclipsed moon away from the lunar nodes. If we take it further away from the node than the previous case, a stage would come when the moon will only sweep across the penumbra, leaving the umbra untouched. This would cause a penumbral lunar eclipse. If we take the moon more away from the node, a stage would come when only a part of the moon would be engulfed by the penumbra. This would cause a partial penumbral lunar eclipse. Let's take the example of total lunar eclipse of 28th July 2018. This is the eclipse map of the moon. You can clearly see the red circle as the umbra and the surrounding grey circle as the penumbra. The moon's left side touched the penumbra at 10:44 p.m. Indian Standard Time and kept moving eastwards in the sky. The moon fully got engulfed by the penumbra of Earth by 11:49 p.m. As the moon touched the umbra, the partial eclipse began from 11:54 p.m. It kept on moving eastwards and fully entered into the umbra at 12:59 a.m., starting the total lunar eclipse. Maximum eclipse occurred at 1:52 a.m. as during this time the center of the moon was closest to the ascending node. The moon started to come out of the umbra from 2:42 a.m., marking the end of the total phase of the eclipse, and was fully out of the umbra by 3:48 a.m. and out of the penumbra by 4:58 a.m. These are the usual sequence of a lunar eclipse. Now we come to solar eclipses. There are also 4 types of solar eclipses, namely total solar eclipse, partial solar eclipse, annular solar eclipse, and hybrid solar eclipse. The sun is 400 times larger than the moon, but coincidentally almost 400 times farther than that of the moon from the earth. So relative to earth, the apparent diameter of the sun and moon are more or less same, about 0.5 degrees. Therefore, during a lunar or a solar eclipse, the earth's surface facing the sun may lie within the umbra or the antumbra of the moon. As in this case, moon casts its shadow on earth. When any part of earth lies in the umbra of the moon, a total solar eclipse is witnessed from those part of earth. As the moon revolves from west to east, the umbra's shadow also sweeps along the surface of the earth from west to east and is called the path of totality. The shape of the shadow casted on earth is usually elliptic, and its eccentricity depends on something called gamma, which we shall discuss in some other video. Like the lunar eclipse, the umbra of the moon casted on earth also has a large area of penumbra encircling it, and any observer on those parts witnesses a partial solar eclipse. Thus, one important difference between the solar and lunar eclipse is that the former is location dependent and the latter is location independent. The character of a single solar eclipse varies from location to location. A total solar eclipse is total solar eclipse only for those parts of the earth where the umbra will pass. For the penumbral part, it is partial eclipse, and for all other parts, there is no eclipse, although all the parts experiencing daylight. Sometimes when the moon is not very much near the nodes, it may happen that its umbra misses out the earth and its penumbra falls on some part of the earth, making a solar eclipse partial worldwide. These eclipses are therefore officially declared as partial solar eclipse, where the lunar disk blocks only some part of the solar disk. We know that the orbit of the moon is not circular but elliptic, so during apogee, that is when the moon is farthest from the earth in its orbit, if a situation of a solar eclipse arises, Moon will cast its antumbra on Earth's surface, surrounded by normal penumbra. So as mentioned before, due to a greater distance, the apparent diameter of the moon would be less than that of the sun. So even during the maximum eclipse, when the sun and moon's center would coincide in the sky, moon will not be able to block the entire solar disk, making a ring-like appearance in the sky, often called the ring of fire. These types of eclipses are called annular solar eclipse, derived from a Latin word meaning ring-like. Sometimes situation may develop such that the point of intersection of the umbra and penumbra lies exactly near the Earth's surface. This may create a condition such as the main shadow sweeps across the surface of Earth. Some locations may fall on umbra and some part falls on the antumbra. This means a same eclipse may be annular for some part of the Earth or total for other parts. These type of eclipses are called hybrid solar eclipse. Let's take the example of total solar eclipse, which occurred on 24th October 1995. Its path of totality went over Kolkata, India. The lunar disk touched the solar disk at 7:32 am, marking the beginning of the partial phase of the eclipse. Total eclipse occurred at 8:49 am and the partial phase ended at 10:17 am. This is all about the different types of solar and lunar eclipses. If you want to know the conditions required for eclipses to occur and about lunar nodes, watch my previous video on lunar nodes. If you found this video helpful, then you can click the like button and subscribe my channel Astro Shakti for more such videos.